Let me see. So a couple of things I want to show you real quick. There's one thing I have to, all right, let me just show it to you. Let's see. Can you guys see my canvas? My canvas.
Yes.
All right, so this is what it should look like for the most part when you log in now, right? It's got up at the top, I think I just recently added this in, the practice final. I put here just a reminder. You guys have known since the first day, or before the first day, when the final is, but there it is again, right? There's a practice final. I will be posting at least the answer key, if not a video solution for the practice final eventually. I've got this updated. I don't think I've put it in the Canvas yet. I got it updated in my own spreadsheet. I just got to update this link so that it shows you your average as of right now. It's still of May 11th, I believe. Later, see how this one says quiz 11? And do you see how this is not checked? So I haven't published it yet. Of course, today is a quiz, right? You guys remember this. It's on the rest of chapter 8. So as soon as this lecture's over, I'll just click that little circle. You'll be able to see it on your canvas, and you can do it and turn it in by tonight. So that's where you're going to go for it. So when you log in, it should look like this. You just scroll down to chapter 8 because that's what it's on. Quiz 11 is going to be right there. It isn't there yet, but it will be. And there's, of course, chapter 9 stuff. I got to add some more homework stuff in there. We're going to look at this sheet today, right? I put it up there in Canvas. I think I put it up there yesterday. All right. So does anybody have questions about the final? Does anybody have questions about homework? Does anyone have questions about anything?
Yes, I have a question. So
Yes.
yesterday, you mentioned the a principle. How to say that? The principal one. So the number.
Oh yeah, yeah.
I mean the number under the radical sign should be equal or greater than 0.
That's right. That's right.
Oh,
Otherwise, it's not real, huh?
0 is okay.
0 is okay because what do you multiply by itself to get 0?
Mm-hmm. So
no. Answer the question. Anybody know what do you multiply by itself to get 0?
A 0. Oh,
0.
yes.
The square root of 0 is 0. Yeah. So it works.
Yeah.
The minute it goes negative, it can't work. Not with real numbers. Yeah.
Yeah. Thank you.
Sure.
Thank you.
Sure. All right.
While you have Canvas open, I think last week you said you were going to post something in regards to denominators that weren't alike for chapter 8. Did you end up posting?
Oh, you know what sucks is I looked for it. Thank you for reminding me, Jamie. I think it might not be on what I've got here at home. I'm worried that it's on my work computer, which I've only been able to access once this semester. So did I finish trying to find it? I think I was trying to find it and it just wasn't here. This little sheet that I had created a while back about like denominators and unlike denominators. So yes, I had promised or at least said I would put something up there, but I'm worried that it's not here at home. Let me see if I can Yeah, I created this worksheet. I guess it's not here. So I'm not going to be able to go back to campus anytime soon. So I need to go through my email. I need to remember to do this. I thought maybe I'd sent it to somebody like last semester that missed a class or something. I might have sent it out to somebody who missed it. So it might be in my sent stuff in my email and then I could put it up, but I don't want to talk about it too much if I can't find it because then I can't share it with you. I have to recreate it, and that's shit. Takes a while. But yeah, I do have something. If I could just find it here, then I could put it up there for you. All right. Anything else? Okay. Let me see. So let me come back out of here for a second. Let me take these guys away. They could stay. I'm not going to write anything up on the board. I want to take a look at this. This is kind of like the last thing we did last time. All right, where did I put it? Where are you? Give me, here we go, there it is. So why aren't you showing up here? There you are, okay, I got you. By the way, also, here's something else I said. Let me just throw this up. I don't wanna, don't write this down. I'm pretty sure this is what it's gonna be, but I gotta double check it. I think I told you guys yesterday that next week, my office hours are gonna have to, you know, obviously it's not gonna be before class because we don't have class next week. So look, I think I'm gonna have on Monday, which is a holiday, but what does that mean anymore? So I'm gonna have some office hours on Monday, and I'm gonna have some office hours throughout the week. And our final, of course, is on that Thursday. So as soon as I get this firmed up and verified, I will post something like that to Canvas so you guys can see what my schedule is gonna be next week. I've got to create those office hour times and then send the links out to you guys too. Is everybody with me on that? So, okay, all right. So those you don't have to attend, there's like normal office hours. So maybe nobody comes and I just sit here and work on stuff with my laptop watching me. You never know, but I will be there at those times. I'll let you know what they are. Let me show you this one now. Let's see. No, there we go. Where'd you go? There you are. Okay, here we go. Oh, all right. Look up here. We did this problem, this specific problem right there. We did it last time. Let me zoom in a bit. We did this problem last time. If you weren't here last time, let's just take a minute and look at this. You take square root of 28, right? Let me kind of review this. This might be good for everybody. Let me turn these guys off behind me. Take the day off, guys. Good song, but just, you know, turn the lights on. Okay. So I'm not going to belabor this, but I really hope some of you guys realize it is a lot like if I ask you to write this as a mixed number. Right now it's improper fraction. I can write this as 8 plus 7 over 8, and then 8 divided by 8 is 1, and I can't do 7 divided by 8, so it stays. Now, you might never have said what you're doing there with those words, but does it make sense what I'm saying? That is what you do. You do the part you can, and you leave the part you can't. Does that make sense? I mean, that's probably a weird way to say that, but it is an accurate way to say it. Now, the reason I say it like that is because if I have something like, let's say the square root of what, Jeff? You could do it. Can you? Yes, I can do it. Yes. Okay. Square root of 18. Can somebody tell me what the answer to that is exactly? No. Can somebody tell me an estimate of what the square root of 18 is?
219.
Whoa, no, right? Square root of 18 is not the same thing as half of 18. It isn't. Not half of 18 additively. We already know what 18 divided by 2 looks like. It's 18 over 2. This doesn't mean, yeah. What's the square root of 16? 4. So what's the square root of 18? A little more than 4. Are you guys semi with me here? Very, very infrequently do we use a new symbol for an old idea. So square root can't mean the same thing as divide by 2 because we already have a symbol for divide by 2, right? So why would we make a whole other symbol for it? So, all right. So the square root of 18 is something gross, but sort of like 15 divided by 8. Isn't that just under 2? It's like 1 point something or other. Because 16 divided by 8 is 2. Are you guys kind of with me? Do you guys see that? Isn't 16 divided by 8 2? Yes? 16 divided by 8 is 2. I don't know if some of you guys are looking at me like I'm crazy because it's not a 16. But since 16 divided by 8 is 2, 15 divided by 8 is just under 2. Since the square root of 16 is 4, the square root of 18 is just a little more than 4. How's everybody doing? It's the same idea of estimation. But now I don't want to estimate. I want to do something similar to this. Because there is a part of 15 that can be divided by 8, namely 8. There is a part of 18, if I break it up multiplicatively, that I could do the square root of. Right? So what is that? How do I break this up? 3 times 6? 3 times 6 is 18, right? But why is that no good? Can I do the square root of 3? Can I do the square root of 6? No, no. Shit. So how do I break 18 up so that I could do the square root of a part of it? All right, so maybe I've jumped into this a little quickly. I don't know. Is there a number that goes in 18 that I can do the square root of? I'm not sure what's happening out there. Are you guys all right? Have I said too much too quickly?
Oh, yes, 2 and 9.
Yeah. So what numbers can I take the square root of easily? Give me a number that I could take the square root of easily. Somebody else. I'll start us off. 4. Go ahead, Jamie. I'm sorry.
You're just saying any number like 25 is 5.
Yeah, 25. Then somebody else give me a different one. Why can I do the square root of 4? Because 4 is 2 times 2. Why can I do the square root of 25? Because 25 is 5 times 5. It's 5 squared. So what number can I do the square root of? Any number that is the square of some other whole number or integer, right? So 18, how can it be broken up so that a part of it is square rootable? So I think somebody said this. I can't remember. Yeah, somebody did say this. 9 times 2, right? Same way I can break up 15 as 8 plus 7 because 8 can be divided by 8 then. And that's how I get to this. So what's the square root of 9?
3.
3. And what's the square root of 2? A good answer is, I don't know. Because you don't know. I've got 3 digits memorized for square root of 2 is 1.414, and then it goes on forever. So I don't even know. I can estimate it really horribly because I left out an infinite number of decimal places. Oops. So square root of 9 is 3. Square root of 2 is square root of 2. I don't know what the shit that is, so I just write square root of 2. Bam. Square root of 18 is 3 times the square root of 2. The same way that 15 divided by 8 is 1 and 7 divided by 8. It's got a part that I could do and a part that I couldn't do. A part that I could do and a part that I couldn't do. Okay, maybe. So this is a slightly preferred way to write this. They're the same. Anybody have a calculator out? All right, somewhere. Do I have my calculator somewhere? There it is. Got your calculator? What's the square root of 18? See what the calculator says. A little show-off calculator. Whatever. You're all hardwired for stuff. Whatever. Does anybody... Am I like excessively confusing today? I'm sorry. You guys look really confused. Just in your calculator, can you put the square root of 18 in your calculator? And then somebody type out what it is. I see what it is. It's basically what Melissa said, and it's what I said earlier, right? It is between 4 and 5. What do you get when you do the square root of 18? Does everybody have a calculator? Am I alone? Are the 2 people I can see, is that a video? Are you guys with me? All right, here. You guys are driving me a little crazy. Yes. Right? See the square root of 18? Right? Don't worry about that shit above it. Look at the square root of 18, right? 4.24. Basically what we thought it was. The square root of 16 is 4. So the square root of 18 is a little more than 4. Now, try 3 times the square root of 2. right? Just like that. What we just did here is we said that they look to be the same. That equals that. Because I can write them, I can rewrite this as this. What is 3 times the square root of 2? It's the same thing. Of course it's the same thing because they are the same thing. No? What's 15 divided by 8? This actually comes out nice. It's not too evil. It's not got too many decimal places. Can you do 15 divided by 8 for me? 15 divided by 8.
1.875.
Good. Now do 1 plus 7/8. 1 plus 7 divided by 8. So you would put it in the calculator like that. And this, supposedly they're the same thing. Show up. Show up. There you go. Are they the same thing?
Yes.
Yes, they are the same thing. Are you guys getting my point at all? So 15/8 is the same thing as 1 7/8. You guys sort of came into the class. You remembered that this is a slightly preferred way to write it. This is. So you guys always want to make every one of these into this, and I can't blame you that much, but at some point it doesn't really matter as much. So in the same vein, this is a slightly preferred way to write this. And to be honest, this is actually a stronger preference. This is even better than this. All right, so let's try another one. Where have I put my eraser? There you are. Come here, eraser. Come here. All right. Oh, red's not a good choice. Red likes to stay there. But you are strong. You're strong. Ooh, that's nice. Get a little higher for that. Let's try this. What you got, Jeff? Yeah. Don't say anything yet. So first thing to realize is there's no way in hell to get just a nice whole number answer. So let's try this. What numbers would this be between?
8 and 9.
8 and 9, because 8 squared is 64 and 9 squared is 81. So square root of 75 has to be somewhere between 8 and 9. So if I said simplify, it's not that kind of question. If I said simplify square root of 64, you just say 8. You're done. This one you can't do that with. But can somebody see how to factor 75 so part of it is a perfect square? So how would you do that? Before you say anything, one way you can do this is start dividing 75 by 2, by 3, by 4, until you get a square left over. 75 divided by 2 is no good, right? Because it's not even. But what's 75 divided by 3?
25.
25. And is that a good number to get right now? 25? Is 25 a good number for this? Yes, because we're talking about square roots. I really want you guys with me. Isn't there's another way to factor 75? What's 75 divided by, sorry?
Why we don't choose 75 divided by 5 is going to be 1.
Oh, look at you. Look at you. So what's 75? You're like right with me. What's 75 divided by 5?
1.
No, it can't be. 5 times 1 is not 75. Try again. What's 75 divided by 5? 15.
Divided by 5.
So watch.
Yes.
Watch. You can write this as the square root of 15 times 5. That didn't do me any good. Can I take the square root of 15? No. Can I take the square root of 5? No. So that is a way to factor 75, but it's not a way to factor it so I can actually do a square root. It's sort of like, remember when we did, do you guys get this? Do you guys get this? Does anyone not get that? Does anyone not understand that? Do you see why I did that? Is that the only way I could have broken 15 up? Isn't 15 10 plus 5? Isn't it? Why is 10 plus 5 make no sense? Because neither one of them is a multiple of 8. I can't divide either one by 8. I'm in the same boat that I was in. But if I write 15 as 8 plus 7, then 8 divided by 8 is 1. I could do something with a part of it. So there are multiple ways to break up almost any number, right? Except for the prime ones and all kind of shit. But you want to break it up in a way that gives you a square rootable number. So you're able to do something. So that's not a good way to break it up. What's a better way to break it up? Well, what's 75 divided by 3?
25.
Yeah, right? Because 3/4 is 75 cents. So we know that. And what's the square root of 25?
Say again?
What's the square root of 25? What's the square root of 25? 5. Okay, what was the part? So it's okay if I need to take a step back, but you guys have got to be with me. So let's take a step back. I don't know if that was too hard of a question or too easy of a question. I don't know.
No, Professor, I have a question.
Yes.
So it's that means 5 plus a square
No.
root of 3 or times 5 times.
So what really sucks, now stay with me. The thing that I hate about the way we look at this, don't I break this up? Stay with me.
Fraction one, I understand.
Stay with me. Don't I break that up using addition? So when I go to this next step, it's going to be 8 divided by 8 plus 7 divided by 8, right? Okay, now stay with me. I know your question was about this, and I go over there. I'm like a politician. I like your question. Let me replace it with another one. But I'm better than a politician. I'm going to come back and answer your question. Can everybody mute yourselves, please? Dear God. Mute. Yes. Okay. So then this will be 1. So when I write this, what is understood to be right there that we don't write?
Addition. A plus.
Now, what's here?
Times.
Times. So that's times. This is one of the worst decisions in mathematical history because it's the only time I have a number next to another number and they don't mean multiply. That doesn't mean multiply. And we know that, but it just is horrible. And that's why I kind of like your question came up. To be honest, I've never had that question before, but it's actually a really good question because you're so used to this meaning addition, and this doesn't because that's addition. So of course there's addition there that we just don't write. That's multiplication, so that's understood to be multiplication the way it's supposed to be when you have something sitting next to something else. Okay, I like it. And it makes sense because what are roots based on? Undoing multiplication. Right? Okay. So let's try another one. What about, I wanted to do this real quick. Can somebody tell me what's the square root of 49? Seven. Right? Can somebody else tell me why? Why? Because my calculator said so. Stop it.
Because 7 squared equals 49.
I like it, right? That's what the square root asks you is what does it take 2 of to multiply to be the number inside? It takes 2 7s to multiply to be 49. So somebody hasn't said a damn word yet. Don't make me call on you. What's this? Thank you, Alex. Thank you, Lauren. All right. Right? Why? Because it takes 2 9s to multiply to be 81. So those are the kind of numbers you're looking for to break up some number you can't do the square root of. So for example, if I have the square root of 98. This could be one that just jumps out at you or not. So one way to do this is to start dividing 98 by squares. And another way to do this is just divide 98 by 2, 98 by 3, 98 by 4. But what's 98 divided by 2? Do you see something useful? What's 98 cut in half? What's 98 divided
49.
by 49? Why is that good? I kind of like how I can point at something from anywhere, right? That's good because I know the square root of 49. So what's the square root of 49?
7.
That looks so weird. It looks like I got a tiny arm. All right, so 7. And what's the square root of 2? I don't know. So we leave it.
2.
No, square root of 2 is not 2. Square root of 2, I don't know it. So that's why it still says square root of 2, right?
It's still the same, you mean?
Say again?
We put the same, number 2.
Same, exactly. It stays the same because I can't do it. Why did this change from 49 to 7? Because that's the square root of 49, which we know. And again, do you guys get? I keep coming back to this. I know I do. And you guys are like, good Lord, Jeff, just stop that shit. But look, 8 divided by 8, I could do. It became a whole number. 7 divided by 8, I can't do. So it stays. 49, I could do. It becomes a whole number. Square root of 2, I can't do. So it stays. It's the leftover shit. That's why this is kind of like a mixed number. A rational number and an irrational number, whereas this is a whole number and a fraction. I mean, there's beautiful analogies there. So the more you know your squares, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, the easier these kind of problems will be. So let me throw this sheet back up here. Okay, get over here. Where is she? There it is. Okay, let me see. There you go. So this is on Canvas. I actually show you 2 different methods. I really push this method hard. And this is the method we've been using. So for example, 54 is 9 times 6. The square root of 9 is 3, and the square root of 6 I can't do. Do you guys see the idea? All right. I took each one of these and I did it a different way. What's the square root? So let me ask you this. Why can I do the square root of 9 but not the square root of 3? Because what does 9 have in it? You could do this. If I break 9 down, it's got how many whats?
2 3s.
2 3s. So I can't do the square root of something unless that thing has 2 somethings in it. Does that make sense? So you actually could, see, I just break down a 4 times 7 and square root of 4 is 2, but you could break it all the way down like a prime factor tree. Remember prime factorization, a little tree you can make? And any group of 2 that you see, you write 1 out there. I personally don't like this method as much because people make really silly mistakes with this method. But I put it down there in case you want to look at it and you like it. So what I want you to do is I want you to do these. And I'll just sit here and somehow still earn a paycheck as I do nothing. Sorry. It's like to give myself a little. So go ahead and try these out. I will come in a minute and check on where we are. Give these suckers a try. I think the square root of 50, I'm almost sure we did it somewhere. But go ahead and try these out. I'll come in here in a minute and I'll see where people are. So let's just try the square root of 50 for right now. I'm going to do it with you here in a minute. Please release me. Whoa. So let me come in here. Square root of 50. Oh, let me see. This will be easier. So how can I rewrite 50? The nice thing is, if you do 50 divided by 2, you immediately get somewhere good, right? What is 50
2 and
divided?
25, and then 5 breaks down to 5.
Yeah, so it'd be 25 times 2. So why did we pick that? Why didn't we pick 10 times 5?
Because 25 can be broken down into.
Yeah. So 10 times 5 is 50, but it's not the right way to break up 50 because neither one of those can be taken the square root of. The problem is I can't do the square root of 50, so I want to break it up so that there's a part I can do. Otherwise, what's the point? And some of you guys are out there going, yeah, that's my question, Jeff. What's the flipping point? So the flipping point is if you can't do this shit, you can't pass. But so if I break that up, whoa, where did you go? Okay. There we go. Let me just show one more step than you really need. Right, if I do that, then the square root of 25 is what?
5.
5. And the square root of 2 is? I don't know. Oops, somebody's chatting at me. Somebody just tell me what the square root of 25. Where's my chat? There it is. Oh, thank you, Lauren. Okay. All right, keep going, guys. Try out the next few, and then I'll come in there and catch up to you. Please release me. Let me go. Yeah, I don't know. Oh, I can put you over there. Neat. Multiple monitors. Seems like it'd be nice, but it can be crazy. All right. Let me catch up with you guys. There's something interesting about number 2. So anyone want to share with me? Somebody I haven't heard from yet, preferably. What your first step was on this? Sorry?
Number 2 is 9 and 8. 8 and 9, 9 and 8.
All right, let's do that. Did somebody else have a different way to do it?
2 and 36, and then
Yeah, so wait right there. I'm pointing over there because that's where I can see myself now, but the camera's there. Screw it. So let's do it the way that Hayam suggested first, just because we're crazy. So square root of 72 is definitely, get over there. The square root of 8, get in there, times 9, right? Just stop it. Hold on. Please cooperate. Okay.
Doing the board better for you.
Sorry? What's that?
I said doing the board better for you.
Yeah, but you know, if I do it typing, then you can maybe read it. That's kind of a new thing for us. Now look, there's nothing wrong with this. There's not a damn thing wrong with this, but some of you guys realize this is not going to get to the right answer yet. So what do I mean by saying there's nothing wrong with this? Well, what's the square root of 9?
3 and 3. 3 multiply 3.
So square root of 9 is?
3.
3. And square root of 8, I don't know, but this is sort of like, I call this reducing radicals sometimes because it feels a lot like reducing fractions, if you think about it. And a lot of times when you had to reduce a fraction, didn't you have to do it in a few steps because you didn't think of a big enough number to divide it by? Do you guys remember that? I ask you to reduce a fraction, you reduce it like, wait a minute, something still goes in, so let me do it again. All right, same thing here. Is there, can you break up 8? How do you break up 8? Don't
2
worry,
and
guys.
4.
I'm gonna do it the other way too, in case you're like, "There's a better way." I know. We're gonna do
2
it both.
multiply 4.
Yeah. Isn't can't you do the square root of 4? Yes.
No?
2.
What's the square root of 4?
2.
2.
2. I said
So
2.
don't forget
4 multiply 2.
the question that a square root asks you is, what does it take 2 of to multiply to be this thing? So square root of 4 I can do because it takes 2 2's. So I can write this. Let me see if you guys see why this is true. Do you guys see that? I'm not done yet. Because tell me, what does this say right there? What does that say? What does mine say? Sweet. What does that one say? Can somebody read that for me? That right there. That guy right there. And you're all like, I'm not going to read for you, buddy. It's not English class. I'll read it.
3, 4, 2.
No. You left out a quote. So it's 3 times the square root of 4 times 2. 3 times the square root of 4 times 2. Well, what's the square root of 4? 2. So now it's
2.
3 times 2 times the square root of 2. So then the final answer is going to be, what is 3 times 2? 6.
6.
Doop. So somebody has suggested, why did I write that there? I have no idea. Somebody had suggested earlier that you could break up 72 as 36 times 2. Which of course is a better way, just in the sense that it takes less work, but you do it the way you see. And then you evaluate where you end up and say, oh shit, do I have to go further? Well, what's the square root of 36?
6.
6. And what's the square root of 2? I love how you're still not used to this. You just say, I don't know. That's the correct answer. I don't frickin' know what the square root of 2 is, so then I'll leave it. Square root of 36, I know. And the square root of 2, I don't frickin' know what that shit is. Oh shit. How do I do this? I want to put a box around you. You're going to let me do it. Screw it. Screw it. That's fine. So you see how I get the same exact answer either way. Okay. So you guys keep going. I'm sorry. Hopefully you feel a little more confident with this going forward. Go ahead. Keep going. There is one of these you can't do. Let me play around with how to get a box around this thing. Here we go. Is that going to do it? No. There we go. Yay.
Can't you do 3 and 2, and then after that you can't do anything else because there's no square roots of anything else?
Where are we? Look at, I'm sorry.
The 6 and 2?
Yes.
Can't you only do 3 and 2 for the 6 left, and then after that you can't do anything else?
All right. I'm not sure what you mean. The 6 left. What 6 is left?
At the end, 6 is square root of 2. Can't you break the 6 down to 2 and 3?
But there's no reason to break the 6 down because it's not inside of a square root anymore.
Oh, okay.
Yeah, so it's sort of like the reason we broke 72 down in the first place was because it was under a square root. And I'm trying to see, is there a part of 72 I can then do the square root of? So the minute we get stuff like out of the square root, they're done. They're just sitting around waiting. Does that make sense?
Yeah, that makes sense.
Okay. I understand the question. And I understand where it's coming from, because this is new. You guys aren't used to this kind of thing. But it is just a matter of getting used to it. So let me check in with you guys. Have you guys started doing this one yet? Hopefully, because that's the next thing.
Is it 10 and 12?
So if we do 10 and 12, can I take the square root of 10 or 12? So let me show you this other way to do this. And again, I'm not going to take points off if you do it this way, but this is a slightly not as good way to do it. So I can take this and break it down into 12 times 10. Now keep going. I can break 12 down. Come on. 12 is 2 times 2 times 3. Is that all right?
There's no square root of 12 or 10.
That's right.
So is there no square root for the problem? Can it be broken down further? Is this the one that you said that there's one that wouldn't?
There's one that can't be done, but this one can be done. So method 2. I'm just going to show you this one time, I think, just in case somebody really loves it. Do you guys see how I broke everything down as far as it goes? 12 is 6 times 2, so it's 2 times 2 times 3, and 10 is 2 times 5. Do you see 2 of anything in there? Do you see 2 somethings? Do you see 2 3s? Do you see 2 5s? Do you see 2 anythings? Yes, you do. What do you see 2 of? And if there's 3 of them, there's obviously 2 of them. So what do you see 2 of?
2.
2. So I can actually, every pair of things, I put one of them out front. That's a really, I personally just, I don't like this method as much because it's kind of weird, but that's what a square root does. What's the square root of 9? 3, because 9 is 3 times 3. And what's a square root do? Cuts things in half multiplicatively. So 9 has 2 3s in it, so the square root of 9 makes it 1 3. This has 2 2s in it, so the square root of that makes it 1 2. That's a little bit weird. So let's look at what this would look like, the slightly preferred method. So you might be able to notice, again, probably the better way to do these problems is to take 120 divided by 2, 120 divided by 3. But then you get 120 divided by 4. Is it divisible by 4?
30?
Yeah. And then what's the square root? So it looks like that now, right? So this is another way to do it. What's the square root of 4?
2.
2. And what's the square root of 30? And again, an acceptable answer is, I don't know. Because I don't know either. And I'm teaching the damn class, right? I can guess what it is, but I don't know exactly what the shit it is. And that's sort of the point. I don't know, so it stays. And down here, just make sure you understand we got the same answer. What's 3 times 2 times 5?
30.
Yeah, so we got the same answer both ways. Okay, maybe. So it's all about, can I break the number inside up into a square times other shit? Because the square I can do and the other shit stays. And sometimes when you do that, like over here, sometimes when you do that, there's another square that you might forget about. Oh, there's a whole other freaking square. So you got to do it again if you don't do enough in the first step. Now, how do I know I'm done here? Because does 30 have 2 of anything left? No, it's got 1 3, 1 2, and 1 5. There's no squares that go into 30, so I know I'm done. Can we stop for a minute? So sometimes it sucks that there's multiple ways to do a problem because it actually makes it a little more confusing, which is why I really want to focus on the first method because there's less guesswork involved with the first method. But the second method, people kind of like it because then they can kind of be focused on just break things all the way down, and then you find, see here how I found 2 3s, so I put 1 3, 2 2s, so I put 1 2, 2 more 2s, so I put another 2, and then the 5 is left inside. I mean, that method is fine. There's nothing wrong with it. It's just easy to make silly mistakes with that method. But I'm not gonna like not accept it if you do it that way. Okay, so go ahead and try this one, number 4, if you haven't tried this yet. I know, this crazy semester is almost over, guys. Well, let me keep this up here in case you guys go to see that. All right, so who's got number 4?
4 and 20.
Okay, that's a good start. So that's a good start. So let's go there. Oh shit, poor little dude. Just stop it. Okay, Jeff, it doesn't exist. There we go, buddy.
So is that what you were saying, where you factor 80 and then the first one that you come across that can be factored, which 4 can be factored because it's 2,
4 can be
but
square
then 20
rooted.
cannot? Sorry, squared.
Now I want to point something out. All right, let me see which way I want to do this. Let's just keep going down this way. Some of you guys might have noticed a different way to do this. So this is going to be one like this one was. So right now we're on the longer path, which there's nothing wrong with that. I didn't mean to say that like it was, we're on the longer path. No. This is fine. So what's the square root of 4?
2.
2. Now look at 20. Can 20 be broken down?
No.
In a good way?
No.
Of course it can.
To 10?
What's 20 divided by 4 again?
5.
Yeah. So I can write it like that. And what's the square root of 4?
2.
Yeah. Darn it. All right. No. No. Get over there. All right. So then the square root of 4 is 2. So I can write this. I agree with you, Hayam. This would have been easier up on the board, but oh well. Right? And then I can write this finally as 4 rad 5. That's my quick way of saying this. That symbol, that square root symbol, is called a radical. Did you guys know that? So that's why the name of this chapter is radical notation, radicals. Totally radical, dude. So this is called 4 rad 5. That's a quick way to say that instead of 4 square root of 5. Now, right up here, there's actually 2 other methods I want to show you. Right up here, you could have realized that 20 has another 4 in it. So you could have written, before you go any further, you could have written this like this. Right? And what's the square root of 4 times 4? It's 4. I see 2 4s, so I could put one of them outside, and then I'm done. Give me a second. Let me rewrite this. And I get to the same place that we got over here. Right? Maybe? No? I'm crazy? I'm trying to box that off. Okay. And then there's even a third way. And I don't know if anybody did it this way instead, but you can break up square root of 80 as the square root of 16 times 5. Get in there. 16 times 5 is 80, and 16 is a square number. And of course, that leads right to this. Let me just put that in the middle so you can, I mean, either way you do it, you get to the same, any of these three ways you do it, you get to the same place. All right, all right. And what about number 5? What's the only way to break up 33?
3 and 11.
Yeah, so there's not any squares in there at all. So that one is already simplified or can't be done or however you want to say it. Don't say prime because 33 ain't prime. Just the square root can't be done. You can't simplify that root. It's like me saying reduce 9 over 11. I can't do it. All right. And then my favorite one is that one. Now, some of you guys, I understand. Actually, to be honest, it just came to my mind because I just don't think this way. Some of you guys might be out there just hitting the square root button and making the calculator do all these for you, but I ain't gonna work on these because if you type in your calculator square root of 72, you're gonna get this disgusting, what do you call it? Decimal. So if I say simplify this kind of problem on a test or a quiz or the final, and you give me a decimal, no. That's nice for your calculator. It gets to pass. You got to take the class again. So go ahead and try number 6. See what you can do with number 6. I know it's a big number. Oh, well. All right, still not there. Okay. No. Let me ask you guys something. I don't know if you guys remember, we talked about divisibility rules. Let me write this answer down real quick while I'm saying. What do you get when you add 7 to 2 to 9? What do you get when you add 7 plus 2 plus 9? Is that not a word?
18.
Word. Sorry?
18.
Yeah, and isn't that a multiple of 9?
Yes.
So isn't that divisible by 9?
Yes.
Yes. Do you guys remember that at all? If you add up all the digits in a number and they are a multiple of 9, then 9 goes into the whole number. So 9 goes into 72 how many times?
81. Oh, I'm sorry.
81. Yeah, 8, yes, you got it. And then 9 goes into 9 one time. So it's 81. And what's really cool about that? What's the square root of 9?
3.
3. And what's the square root of 81?
9.
9. What's that mean, Jeff? What's going on with your voice? I don't know. So square root of 9 is 3, and the square root of 81 is 9. So I get that. Do you guys see that? That's almost too nice to believe. Now, is that the only way to get to the right answer? Because now what's the right answer? Obviously, it's freaking 27, right? So sure enough, 27 times 27 is 729, which is kind of nifty. Maybe not excessively nifty, but too bad. Okay, let me see. So that one just happened to be already a perfect square. It's just that none of us have 729 memorized like we do with 16. Okay, so any questions from that sheet? So
No.
Here's some good news, guys. I'm not going to do, this is where we end. This is the last new thing we're doing. I'm going to go ahead and make like 9.3 and 9.4 extra credit if you want to try them out. 9.3 is sort of like, what can we use this for? So it is very cool. You know, I'm probably the only person here that would call it that, but it's kind of like, okay, we know how to do this. What is it good for? So that's what the very next section does, is it shows you what this ability is good for. But considering everything, I want tomorrow and Thursday to be focused on review for the final. So we have finished all of the new stuff that we're going to do for the semester. So just, I want to put this other thing up here. Darn it, where are you? Please. Nope, you're not there. All right, I'll do this. So don't forget, somebody's chatting at me, hold on. Don't forget, oh, celebration, all right. I understand, I'm not gonna take it personal. Here, so the practice final is up on, whoa. There we go. Is up on Canvas. There it is. Then look at all that. Look at that in all of its glory. So we go all the way back to chapter 1. Yeah, buddy, it's cumulative the way it's supposed to be. I don't know why it's really poorly formatted. So maybe I should go in there and do something about it. But right, and then so I'll have like either the solutions or maybe even a solution video up at some point. I'm not gonna commit to that. But that's up there if you want to try that out. In the next couple of days, we're going to focus on, what do you call it? Review. There it is, Jeff. So reviewing to get ready for the final.
Will we have a similar amount of problems on our final? Close to this?
No. This is, let's see, this is probably a little bit longer than the actual final will be. Normally my finals have just under 30 questions total, like 1, 2, 3, 4, 5 is right there, right? So I think this might be a little longer, but it shouldn't be too much shorter than this. Remember, we're gonna have 2 hours for the final. Okay, so, you know, your main priority is doing the homework. And then your second priority right now is taking a look at this practice final, because the final is looming. It's our next big thing, and it's the heaviest weighted thing individually, right? So you want to be ready for that. The nice thing is, though, it's way overweighed by what you're going in. So if you're going into the final with a decent grade, it's going to be really hard for the final to make you not pass, because it's not nearly as powerful as everything we've already done is. I don't know if that makes sense. Everybody always, the final is the heaviest weighted individual thing, but we've got such a high percentage of your grade figured out already that the final by itself can't knock that around too much unless you make it very low or a very high grade. Anyway, so that's out there.
I have a question.
Yes.
Do we have today a quiz?
Yes.
Okay.
Yes, so that's one of the first things I showed you was where that's going to be exactly. So just to show you this again, when you log into Canvas, as soon as this class is over, or you know, within a couple minutes after this class is over, if you scroll down to chapter 8, it will show up right here. Can you see this quiz 11 right now? No, because I haven't published it yet. You can't see quiz 11. You can see it over here because this is my account and I'm special. You can see quiz, but you will see it right here the minute I click on this. So I'm going to do that in just a minute. Are there any other questions? Oh, we're right at the time. Not bad. Any other questions, guys?
Thank you. Don't forget the makeup quiz.
Yeah, don't tell me here. You got to email me.
Oh, email. Okay.
Please.
I forgot to email you.
Because you tell me that, it's not going to stick in my head. and I got a meeting I got to go to. It's going to be gone. So you got to email me,
Okay.
remind me. Okay.
I'm gonna email you now. Okay, thank you, bye.
All right, guys. I'm going to click this right now. Bam. So now it should be up. So go get
Thank you.
it. You're welcome. Anytime you want to quiz, I got it. All right, guys. I'll see you tomorrow. Go celebrate with Alex. Bye, everybody.